Hi, so I'm Steve Holloway, and I work as a verification engineer for Dialog Semiconductor. I'm actually a principal engineer now, so I've just been promoted in the last 30 seconds. So we're kind of, just to introduce what we do, we're sort of more or less competitor to Wolfson, what Wolfson do. We actually produce integrated power management and audio processing ICs for mobile smartphones, tablets, involved in telephony. So we have quite a wide. So I'd expect our verification challenges to be quite similar to Wolfson. So I would say that for anybody that's sort of working in any kind of constrained environment as we are in terms of resources, increasing complexity, shorter design cycles, then the first challenge is sort of getting the job done, verification completion, finishing verification within the allocated time. So the sort of problems that we have, I mean, we have relatively simple designs compared to the sort of other speakers that have been on. However, we do have a lot of designs to do. We have a lot of very short design cycles. We have some hard to verify designs for kind of legacy reasons. So we have to sometimes deal with sort of spec issues in terms of force specification or feature creep, features creeping into the specification as a project. So in terms of the resource limitations that we have to deal with, well, I think if we go back to Andy's presentation earlier on, we find it quite difficult to get hold of dedicated verification engineers. So we have dedicated teams. They would be essentially producing a verification environment and then used by the general visual learning. That's the problem in itself on the C side, not necessarily that conversion with the hardware verification languages and the sort of OO software technique really build on. And the other problem that we see is that within the verification domain, there's a real proliferation of methods and tools. Obviously, there's a sort of amenable to formal, sometimes amenable to dynamic, some knowledge of assertion, goes to the mix, and there's obviously lots of different other verification languages and methodologies to go with them. So the problem with that is then that we need to find people that actually cope with all this stuff. Within our organisation, we have people that are specialists within any one of those specific domains, but it's quite difficult to get all round. Second sort of challenge, I would say that okay, so we're all using the UVM or the ERM or whatever it is. We're using reuse methodologies which have the kind of the idea of reuse very much thrown into their DNA. But that requires good upfront design to work, even from module to module or module to vertical reuse. I think, and that's fun. So many times I see on a project where verification engineers are essentially putting all these UVM macros in for factory registration, and then essentially going back to cut and paste reuse isn't really kind of missing the point. So somehow we need to try and ensure this sort of good practice in terms of writing reusable environments from the ground up. So maybe guidelines or some kind of linting that we need to do. And then another sort of related topic is development and selection of verification IP, whether that's internal or external. It's always an issue to decide whether you're going to pick an external VIP and what the trade-off is in terms of the effort required to sort of develop it internally versus the cost of buying it externally, and how to control the quality of that, and generally you find issues with verification IP towards the end of a project. It's sort of Murphy's Law. And the third challenge, I think it's echoing what Andre said a couple of minutes ago, is that it's really moving constrained random or metric-driven verification into the into the mixed signal space. So we really do a lot of designs which are kind of really big A, little d. And traditionally, the sort of mixed signal would have been done in sort of, from the analog point of view, it's quite an ad hoc verification technique. And some of the issues that we do see again and again are sort of quite simple in inverted commas, not very complex, connectivity issues even between analog and digital, which we need to identify and close those down very early on in the project cycle. But unfortunately, these things don't only tend to get found towards the end of the project, because that's when the mixed signal environment gets built up. So what we are endeavouring to module level, some of the issues that we have with the choice and fidelity and creation of the analog model, the current level and approaching the mixed signal coverage model and interfacing between the analog and digital teams, because it's a real paradigm shift. The analog verification guys don't really know anything about regression or constrained random or metric driven. So that's not in their sort of vocabulary. And the digital team considers the analog to be a bit of a black art. So I think it's a real challenge to try to group together to enable metric driven. Okay.
Yeah, we do have time for a question for Steve, if there is a question for Steve. Okay. Thank you, Steve.